Hello there, welcome to another Science Saturday. I'm your host, Noah Mugen. I hope you had a wonderful spring break and a very green St. Patrick's Day, and we're glad to have you back. Today, we're going to be going over the science of light and how it can bend and refract to form rainbows. I'm going to quickly go over the materials that we'll be using in today's experiments. Now, if you don't have all these, don't fret. It's easy to follow along even without doing it yourself. Today, we'll be using a flashlight, a mirror, a glass and some water, a dark object, paper, a marker, and a sunlit window. Now let's just start by going over what light is. Things can get pretty complicated if you try and get into the nitty-gritty of light and all its different properties, but in general, light is a beam of energy made of something called photons. Photons are small particles released by something like the sun or this flashlight. They travel in a beam, and that's what light is. When light moves, it doesn't actually go in a straight line. Instead, light moves in a wave, like something you'd see at a beach. These waves of light can have different wavelengths or distances between the peaks of the waves, and those wavelengths determine how the light appears. We humans can detect light within a certain range of wavelength, which is called visible light. If the wavelength gets too long or too short, our eyes can't see it. For example, the radio in your car uses radio waves to pick up whatever song you're listening to. Radio waves are actually another type of light, but since their waves are too far apart, we can't see it. Within the light we can see, the different wavelengths of light determine what color it is. Violet has the shortest wavelength of visible light, while red has the longest wavelength. White light, or what you might think of as normal light, contains all these different colors together, and black is just the absence of light. And the colors of light behave differently than you might expect. When you're painting, do you know what the primary colors are? That is, the colors that all the other colors can be made from? That's right, it's red, blue, and yellow. Red and blue make purple, blue and yellow make green, and yellow and red make orange. However, light actually has different primary colors, being red, blue, and green. All other colors of light are combinations of those, and when you put all three of them together, they make white light. If you shine red, blue, and green light at one spot at the same time, you're going to get a white light. Because remember, white light is the combination of all the colors. And since all the colors are made from red, blue, and green light, then if you just combine those three, you're going to get white light. And light behaves differently when it interacts with different objects. We can show this using a flashlight and a clear object like a glass, a dark object, and a mirror. First, grab your mirror. When you shine your flashlight onto the mirror, what happens? That's right, it's reflecting the light, and the light is bouncing back onto another object. But now what happens if you shine it onto something like the glass? The light passes through the glass and hits whatever is on the other side. While the mirror will reflect the light and make it bounce back, a transparent object will have the light pass through it. But now what happens if you have it hit something like a dark object, like this sock? Well, the light isn't passing through it, but it's not reflecting either. The sock is absorbing the light. And this all relates back to how we can see. Our eyes work by receiving light from our surroundings, which tell us about the world. But wait a minute, you might ask. If you and I aren't mirrors and we don't reflect light, then how can we see each other with light from bouncing off our bodies? Well, the truth is that we do reflect light. Almost all objects reflect light in some way. Take this Lego for instance. Red and blue light are absorbed when they hit this Lego, but when green light hits it, it's reflected back into our eyes. That's why we see this Lego as green. For this white Lego, all lights are reflected. For this black Lego, only a little bit of light is reflected, and almost all lights are absorbed. Every object reflects light at least a little bit. Lighter objects reflect more light, while darker objects absorb more light. Most objects are actually rough when you look at their surface at the size light would interact with them. This means that when a beam of light hits the object, light is scattered in all different directions. That's why you can see an object regardless of where you are standing. Because the surface of the object is rough, the light photons are scattered, meaning that everywhere, including where you're standing, gets some light reflected onto it. On the other hand, mirrors are so smooth that light isn't scattered at all, and instead is reflected back at an identical angle. That's how light preserves the image after hitting a mirror. Now, since most mirrors reflect any color of light, and you can see it just like your eyes would, that means mirrors are technically a smart white. Interesting, right? And light can act pretty strangely when it travels between different mediums, like between air and water. A curved surface, like a raindrop or a cup, will cause light to bend in a process called refraction. When light hits the curved surface of a cup full of water, the water acts like a convex lens and bends the light inward. This point where all the paths of light cross is called the focal point, and at any point past that, the beams of light have been bent inward so much they've actually switched positions, creating a mirror image of what the object actually looks like. The curving of light can actually be shown pretty easily by reversing an image. For this experiment, all you're going to need is a marker, a piece of paper, and a full glass of water. First off, just draw a small arrow on your piece of paper. Now, take the paper with your arrow on it and lower it behind the glass. If you get it at the right angle, you should see that the arrow has switched directions. The curving of the water has caused the light from each side of the arrow to be curved inward and be on the opposite side from where they started. This is just one example of how light can curve based on moving between mediums. And the thing is, not all light curves equally. When a beam of light hits a refracting surface like that of our cup, the different wavelengths or colors will bend in different amounts. Shorter wavelengths will bend more, while longer wavelengths will bend less. This means that when white light hits a refracting surface, the different colors that it is made of will separate based on their wavelength, with violet bending the most and red bending the least. And this is exactly what happens in the air after a rainstorm. Sunlight hits the water droplets that are still in the air, which then refract the light and separate the light based on the wavelengths into different colors. This gives us the classic rainbow. And you can use this refraction of light to make your own rainbow at home. All you're going to need is a cup of water, paper, and a sunlit window. Place your paper right in the sunbeam. Now, hold the cup of water right between the paper and the window. You're going to need to move it around a little bit to make sure that you got the right angle for the sunlight to meet the curvature head on. But once you have the right angle, you should see a nice little rainbow on the paper. The curved liquid is causing the sunlight to bend, and the different wavelengths of colors are being separated, forming a rainbow. And cups aren't the only way that you can make your very own rainbow at home. You can also use a sprayer or a garden hose to create a mist of water droplets, which sunlight can hit and then refract off of to create a little tiny rainbow, much like after a rainstorm. Bubbles also provide a curved liquid surface for light to refract off of, which is why soapy bubbles usually look kind of shimmery and rainbowy when you put them outside. And there you have it. Rainbows are really just light behaving in a strange way, as the sunlight is bent and the colors are separated by the water in the air after a rainstorm. Unfortunately, this means that you're never going to actually find the end of a rainbow. However, they're still beautiful to look at, and knowing the science behind the rainbow just makes them all the more interesting. Well, that about wraps up another Science Saturday. I had fun learning about the science of rainbows, and I hope you did too. Stay safe, have a nice April, and I'll see you next month. Bye-bye!